Hello ROS developers and welcome to the ROS questions and answers video series. If you want to learn anything about ROS, this is your channel. ROS navigation, ROS with drones, ROS for autonomous cars, everything ROS is here. Learn ROS step by step and push your ROS learning in just 10 minutes of video. I am Alberto and today we are going to do a little special video because I'm not actually going to talk about ROS questions and answers. So I'm not going to do a question from the ROS forum, but I'm going to talk a little bit about the baselines and how to use them with ROS. So yeah, but before anything else, remember to visit our Robot Ignite Academy, our online academy where you will find practical online ROS courses using simulated robots, no installation required. You will find a link to the academy in the video description. Now yes, let's start with the video. So as I've said, let me close this. Today I'm going to be talking using the OpenAI baselines, which are a set of RL reinforcement learning algorithms that we can use. But the thing is that these OpenAI baselines work with Python 3. So as you can see, baselines require Python 3 at least. So they don't work with Python 2.7. And ROS, as you may know, ROS Kinetic, works with Python 2.7. So here we have a conflict in terms of Python. Then I'm going to show in this video how we can do a workaround to work with ROS, that uses Python 2.7, and using baselines which work with Python 3. So yeah, for that I'm going to use RDS as always, ROSDS, and here I'm going to use this project, which is already a public project. I will share it in the video description. Which includes an example of the carpool, yeah. So so it has some examples in order to learn with the carpool environment. So let's open this project first of all, and this includes some basic algorithms like QLearn, for instance. Some modified versions of QLearn, but they are currently working. So the carpool is learning how to stay up. So yeah, let me open a shell. Let me open an IDE as well, and let's start a simulation also. Here in the carpool description, the main.launch, we are going to start the carpool 3D simulation. And basically here what we have is these carpool tests packages, which contains launch files for different trainings, scripts as well for different trainings, and some configuration files for fine-tuning the parameters required for the training, etc. And all of this works, it's learning with the OpenAI ROS package, which you can see here, which contains different environments, one of them being the carpool. So here we have the robot environments and the task environments. In the robot environment you will see many, so the Sawyer robot, shadow hand, the WAM, powered drone, and here we have the carpool environment. And the task environment for this carpool, it's this one, carpool stay up, yeah? So we have here the task environment and the robot environment. You can learn, if you don't know a lot about OpenAI ROS, you can come to the official wiki page of ROS, where it is everything explained, how to run different demos, how the different environments works, the training script, the task environment, robot environment. Here you can find extended information about this. In the video I'm going to go fast around some topics, but yeah, here you can find many videos, explanations, demos, etc. So yeah, So basically, here we have in the here. Let me minimize this. In the carpal tests package, we have many scripts and many different learning algorithms. Well, actually, they are. I think they are using Kulearn or some modified version of Kulearn, but the training scripts are different versions. And yeah, but all of them are using the OpenAI ROS structure. Yes. Then yeah, let's see. The simulation has started. Okay, yeah, here we have it. Here we have the carpal environment. So let's try an example one. So for instance, ROS launch, carpal tests, start training. As you can see, you have many different launch files. So let's use, for instance, the origin and Kulearn. Okay, there we are. And we will see now how our carpal starts doing different steps, trying to stay up. Well, trying to learn how to stay up. So here you can see the episodes. You can see episode 19, 20, 21, the different episodes, the time of the episode, the reward, etc. Yeah. So yeah, if we leave this for many episodes, at the end we will see how it is learning. We can visualize how it is performing, how it is learning with the training iterations here and the episode reward here. So now it's quite random, but if we leave this for enough episodes, at the end we should see how this creates an chart that keeps going up because it's increasing the reward because it is actually learning. Yeah. So let's close the reward chart. Okay, so yeah, let's stop this training and let's go for the topic of the video, which is to use the baselines. So yeah, how? Because for this we are only using Python 2.7. Here there is no Python 3 involved. But now, if we want to try to apply some of the algorithms from the OpenAI baselines, we will need to use Python 3. So what can we do here? Okay, first of all, what we are going to do is to download the baselines packages. So let's come here to our workspace and let's do a git clone of the baselines package. And now, what we are going to do is, inside the baselines package, we're going to create a Python 3 virtual environment. Yeah? How can we do this? Okay, so this is done with the following command. Virtualenv. Now we specify the name of the environment. In this case, I'm going to call it venv. And then here we specify that we want to use Python 3. Now this will create our virtual environment based on Python 3, which will use Python 3. And this will create here this new folder, venv. So now within our Catkin workspace, you will see that we have the baselines package, which we have just downloaded. And here it has created this venv directory, which is our virtual environment. Now, in order to activate this virtual environment, to enter, we just have to do a source of the venv bin folder and activate. Now, with this, you can see that here in our prompt, this venv appears, which means that now we are inside the virtual environment. Okay. So now basically we're going to install in our virtual environment everything we need. First of all, we will need to install TensorFlow. So let's install TensorFlow using pip. This may take some time because TensorFlow is quite big. So let's just wait. Meanwhile, what we are going to use the deepq example from the baselines. So here in our baselines package, if you open the baselines folder, you will see that there are many algorithms: PPO, HER, deepq, bench, Acer. So what we are going to be using is deepq. So okay, it has finished. So let's continue with this. We are going to now install currently the baselines packages. So pip install -e dot. So let's install our baselines package. So yeah, as I was saying, what we are going to be using for this video, this example, is deepq, which basically is an algorithm that combines Q-learning with deep neural networks. So what this does is to allow us to do trainings for more complex and high dimensional environments, like we have in robotics, for instance. So yeah, this has finished installed. Now we will still install some things that we will need for the training, some packages like, for instance, PyYalm. We are going to install as well ROS package. These are smaller, so they go faster. Also, let me install the Capkin package. What else? Exception. Yeah, I'm going to install as well the Fused XML. Oh, sorry. Then MPy and NumPy I will also install. And yeah, I think that's all basically. So I think I have installed it. If not, we will see now when we try to execute the algorithm if we have any error. But basically I have installed all the packages I need for my training. So yeah, now it's time to actually start the training. So for that, we are going to come here to our deepq, to the deepq folder from baselines. And here we will see some Python scripts and the experiments folder, where inside this experiment folder we have this trained carpal algorithm, this trained carpal script, which basically is the script that starts the training. Now here we will need to do a couple of modifications, adaptations, very simple, in order to connect this deepq training with ROS, with the ROS environment and with OpenAI ROS, with our OpenAI ROS structure. Yes, this structure that we introduced before, where we have our carpal environment and the task environment. So what do we need to do? First of all, we'll need to import into our script ROSPy, since we are going to be using ROS, and we need to import the ROSPy module. And we will need to import, if we come here and we take as an example one of the basic algorithms we were using in the first example, in one of these scripts from the carpal tests, oops, for instance, let's take the original one here. This was the one we were using. So let's try training original. Here we can see how we are importing our environment. It's with this line. So let's get this line as well and copy it here. So here basically what we are doing is from the OpenAI ROS package inside the task emps and the carpal stay up folders. So if we come down here, we will see it better. So from the OpenAI ROS package, which is this one, from the OpenAI ROS package inside the task emps folder, and inside the carpal stay up folder, I want to import the stay up script environment, which is this one. And this environment is the one that will manage all the rewards and everything for the carpal to learn how to stay up. Yeah? Then, yeah, so we are importing here our environment. Then we will need to, inside the main function, create a ROS node, as always that we work with ROS. So ROS by init node, let's call it, I don't know, let's see how it is called here. So yeah, let's just copy this line so that we, here it is, train carpal. So let's just copy this line where we are initializing the node. And as well, we can copy the line, which we also need, where we create our environment. So basically we need to select the name of our environment, which as you can see here, it's carpal stay up v0. Yes? So we need to initialize this environment. So let's change here the environment name. And yeah, basically that's all. So as you can see, we have just imported some models that we need in order to work with ROS. We have imported the ROS.py module. We have imported the file that contains our environment. Then we initiate a ROS node and we create our environment here. We initialize our environment here. So super, super simple. As I've said before, if there are some steps here that you missed, I recommend you to, or even in our Robotic Night Academy, which I talked at the beginning of the video, we have a complete course explaining this OpenAI ROS structure and how to work with it. Here you have it. So yeah, so we are ready for trying out our deepq algorithm using the baselines. So let's come again here. And yeah, so let's try out our deepq algorithm. So now let's come to the folder. It's this one, deepq experiments, and now we can execute. We need to be inside our virtual environment, as you can see here. Yeah. So for exiting the environment, you can just click on deactivate. But in order for this to work, we need to be inside the virtual environment because we need to be using Python 3. And for that, we need to be inside our virtual environment. So let's activate our virtual environment. Oops, sorry. I cannot enter from here. SRC, source, pen, VM. Oh no, need to. Okay, now activate. Now it is. Now we are, as you can see here. So baselines. Experiment. deepq experiments. And now let's launch our script, which was train carpal. So let's execute it. And now we should see our carpal start to do things, start to learn. And there we have it. So now we have our carpal environment learning through the deepq algorithm. So through the OpenAI baselines. And this is very interesting because ROS is working in Python 2.7. But the algorithm is working in Python 3. Yeah? So this is very useful because we can use and take advantage of the powerful implementations of the baselines package within ROS, even if they use different Python versions. And yeah, so as you can see here, you can monitorize how the training is going. the number of episodes of the training, the mean reward, the number of steps, etc. So yeah, that was all for this video. I hope you have enjoyed it. You have learned something new. If you have liked the video, please give us a thumbs up and subscribe to our channel because we publish a new video every day. And either you like the video or not, please share your comments, your thoughts, any feedback in the comments area. And yeah, goodbye and see you in the next video.